So in this lesson, we are going to be covering a new topic in a branch of mathematics called conics. And conics, you can take almost an entire class of it in college. But basically, what we study is an idea that, let's suppose we had something that looks like an hourglass, right? So we have something that resembles somewhat of an hourglass, right? And so basically the place where conics came from is, think of something like, something similar to two cones. Let's just assume we had those. And what we were doing is we were looking at different cross sections of these conics. All right. So we're looking at different cross sections. And when we make different cross sections, we come up with four that we really want to study, right? Four that are of interest to us. One of them is called the circle. One of them is called the ellipse. One of them is called the parabola, which we have already studied in an earlier lesson. And one of them is called a hyperbola. Okay, so I've written them really in no particular order, but the least common one would probably be the hyperbola that's not often asked about or discussed because it's the idea behind it is a bit difficult for a lot of people, especially at the high school level, but we definitely want to take a moment and think about that. So let's just assume that I took this hourglass and I kind of cut it straight through, right? If I cut it straight through and I took this piece and I showed it to you, what you would see as a cross section is something that is circular. And so by cutting this hourglass looking device straight, we ended up with something that looks circular. Now let's suppose that instead we wanted to cut it at a bit of an angle, really. Okay, so we give it a bit of an angle and we cut it like this over here, right? And so now when I actually show you the cross section again will actually look more oval than it'll look circular, right? So that's the second cross section, and this becomes known as the ellipse. In that similar manner, if I decide that I want to cut this piece in a different manner, where I essentially cut it such that one piece is outside and one piece is going through, like this over here. And so then I take this piece that has been cut, right, and I show you the cross section of it, and what you'll see is basically something that looks like that right there. And so that would be a parabola. That would be a parabola. Of course, take the top off of it, sort of a thing, right? And finally, the most difficult one for a lot of students to understand is the one where we cut it in a very different type of manner, right? So let's talk about that. So let me just kind of erase this piece right here and redraw this hourglass looking thing. And so if we were to cut it straight through, like this over here, right? Let's suppose we were supposed to cut it straight through like this over here. What would happen is basically you would have a shape that would resemble like basically two parabolas, right? Like two parabolas, one facing up, one facing down like that. And so this shape becomes known as a hyperbola, right? So basically it's this conical looking thing that we cut in different kinds of ways, and we end up with four different type of conic sections. So in lesson 17 through, I believe, 20, we basically study these conical sections. Now, my drawing barely does the proper amount of work to show this to you, so I've got something more for you. I've got basically a diagram that does a much more beautiful job of explaining exactly, what shape was cut how. But what you want to really focus on here is basically look at those. They did an amazing job with these models here. Just kind of focus on those shapes that are created every single time. And those are the cross sections, right? That's the last one, the trickier one. That's the hyperbola. So it's just showing you how we end up with each one of these shapes. So the first 4 or 5 minutes, I kind of did a from scratch drawing for you, but essentially did not need to do that because you've got these drawings right over here that are explaining the same thing to you. Now, if you recall from a previous lesson, we discussed parabolas, and we had quite a formula for it. We had something of the sort y minus k squared is equal to 4a multiplied by x minus h, things of that sort. And then we would kind of switch things around a little bit. But these type of formulas were discussed already, and they were for the parabola. So we're not going to be discussing the parabola because it's already been done, but we're going to be discussing the circle, the ellipse, and the hyperbola as we go through these lessons. All right, so now here's something else. No, it says on the top that it was in lesson number 9 that I discussed parabolas with you. And so in lesson number 9, we already did parabolas, and parabolas actually, they're the most involved conic, right? They have a lot of different ways that they can open, and there is just so much stuff that you have to be focused on as far as the distance, the vertex, the focus, the directrix. There's many things in a parabola that are important. Now, in circles and ellipses and hyperbolas, here's the neat thing. You learned circles in geometry, but we are going to repeat them again, right? So you already learned circles, but we're going to be starting with circles, and in a following lesson, we'll do ellipse, and then we'll eventually do hyperbola, right? So let's go ahead and start with a circle. You want to write down the equation of a circle is x minus h whole squared plus y minus k whole squared is equal to r squared. So that is the equation of a circle. Now, we're going to get straight to answering some questions. So it says writing the standard form of the equation of a circle. It says write the standard form of the equation of the circle with radius 5 and center -3, 6. So we know that the radius of this circle is going to be 5, and the center is going to be located at -3, 6. So what we may do with this is, knowing the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. All right, so what we can do is we can go ahead and plug in the values of the center. So the center is at h comma k, so that becomes x minus -3 squared plus y minus, so there's the 6 over there, and that's going to go in the spot of the k, so y minus 6 squared is equal to r squared. And so r would be the number 5, so 5 squared. And then you can simplify a little bit, but basically you can have x plus 3 squared plus y minus 6 squared is equal to 25. And there you go. We have written the equation in the standard form of a circle. Now, one of the things that students really struggle with is memorizing this formula. So you want to take a moment and get acquainted with this formula and be comfortable with that formula, because it's usually a formula that's discussed on the ACT exercises a lot. All right. Now, let's go to another exercise that involves graphing a circle this time. So now let's work backwards. All right, we know that the format of the equation of a circle is supposed to be x minus h whole squared plus y minus k whole squared is equal to r squared, right? That's something that we just learned a moment ago. But you'll notice something, that where there's supposed to be a minus sign, there's actually an addition sign. And then where there's supposed to be a minus sign here, there is a minus sign. So it's like, wait, what gives? How can that possibly be? So one thing you got to understand from this is, in fact, the original equation simplified x minus -3 squared plus y minus 2 squared. But then again, that was not the issue anyway. And that is equal to 4 squared, right? Because the square root of 16 is equal to 4. And so the radius must be 4 squared. All right, so now let's go ahead and determine what's the center. So the center is supposed to be at h comma k. And so therefore, in this situation, the center of our circle is at -3, comma 2. All right. So one thing that I always share with students is a quick way to go from here to telling the center right away is simply switch the signs. And if you remember to switch the signs, you really cannot go wrong with it, because by switching the signs, and you want to remember this, by switching the signs, the positive 3 becomes a negative 3, and the negative 2 becomes a positive 2, like that. And so then you cannot go wrong with it. Or if you don't want to do that, you may go ahead and turn it into, you may write down the original format underneath it, and then underneath that restructure it so that it looks like x minus h squared plus y minus k squared is equal to r squared, and then again you can tell what the center is. Now, let's go ahead and find out the radius. The radius of this circle is going to be 4, right? Because again, the number that is given to you is not the radius. The square root of the number that is given to you is the radius. So the square root of 16 was equal to 4. Now it does say graph the equation, so we're going to take a moment and we're going to we're going to put a piece of graph here, and then we're going to graph on that piece. So here's my graph paper, and I'll begin by going to -3, 2 on my graph paper. So -3, 2 is right over here, and I'll go ahead and label it as -3, 2, and I have my center. Now my radius is supposed to be 4 units, so I'm going to go 4 units up. I'm going to go 4 units to the left. I'm going to go 4 units to the right, and I'll go 4 units down, like this. And then what I can do is do my best in sketching basically a circle that contains those 4 circles there. So those 4 coordinates there, right? So here is just a rough sketch, right? It doesn't have to be exact, it's all right. And so here is my circle. All right, so after you're done with that, that's the end of the question basically. All right, you can be a little bit more detailed and describe what those coordinates are, and generally that's a pretty acceptable technique. Is we know that this is 1, 2. We know that the top is going to be -3, 6. Again, because you're simply going 4 units up, you're going 4 units across, and like that. Then you'll have -7, 2, and on the bottom you'll have -3, -2, like that, right? So you've got the entire graph of the equation. Now, if you're having a little bit of difficulty understanding how I have my graph, you're welcome to look at a completed graph, and notice that even in the completed graph, we've made sure to label those endpoints right there. So generally, you earn points for labeling those endpoints. I mean, they're not really endpoints, but what those are useful ways to actually graph our circle. All right, so we've got a circle. It's at -3, 2, and it's got a radius of 4. And notice that you can take that same thing and you can make an equation out of it at any point, because you do know its center and you do know its radius. So as long as you have these two going on for you, you may go ahead and set up an equation of a circle. All right, now let's discuss the general form of the equation of a circle. So in this situation, the general form, notice, so the general form, it's a very uncommon form, but the general form is different than the standard form, because the standard form is actually, the standard form is factorized. All right, so it's a factorized version of it. And so because of that, usually what happens is to go from the general to the standard, it requires factorization, all right? So in a later part, we'll talk about how can you factorize what you have, but essentially you have x squared plus y squared plus some constant times x plus some constant times y, and then plus c is equal to 0, and that is the general form of the equation of a circle. So now what we have is, it says graphing a circle whose equation is in general form. So the first thing that we need to do is we need to go ahead and put this into its standard form. All right, so I'm going to go through a number of steps with you and try to detail them for you as we go through. But basically, this is going to require a skill that we've learned earlier, and you're welcome to go back to, I believe, lesson number um, 12, maybe I think it was, or basically the factorization lesson, and look up how do you complete the square, right? So completing the square technique, all right? So if you go back to that lesson, you'll relearn a lot of the things that are missing. Okay, so let's go ahead and start. First thing that you need to do is you need to write down x squared plus 4x plus, and now what you want to do is you want to put a parenthesis. I'm going to put it in red for you, so I'll put a parenthesis and put divided by 2 and put squared on the top right, right? And in that space that's remaining, I'm doing this on purpose where you kind of get to know what do you put there. So everything that's in red here needs to be always be placed there. Then based upon what is in the question itself, in this case it was the number 4, so we go ahead and we put the number 4 right over here, okay? And then we go to the next piece. Now we're going to write down plus y squared, right? And then we're going to take the minus 6y, and we're going to do the same exact strategy. We're going to put a plus sign, and then we're going to put a set of parentheses like this. We will put a divide by 2, and we'll put a square there. And this time, notice how the number that you have is the number -6, or you can just say 6 because anything that's going to be squared is going to become positive anyway. So because of that, you put the number 6 in that spot, right? So let me put it in a proper color, which is the color black, so just to be consistent, right? So again, where the arrow is standing, that's basically what we plug in to that parenthesis. And the divide by 2 and the square are always going to be there. Okay, and now while we're doing this, the next thing that we're going to do is we're going to bring this 12 over to the right side so that it becomes a -12, like that. All right, and so in completing the square, the logic is whatever you placed on one side, you had to place it on the other. So literally, just so it makes sense to you where we're getting these things from, this 4 over 2 squared, we simply need it again, right? And we need it on the right side because we're trying to balance an equation. That's the idea. And then this plus 6 over 2 squared, we need it again as well. And the reason why is because we're trying to balance an equation. So anything you added on the left, you also add it on the right. Okay, the only difference is the one that is on the right, you want to go ahead and simplify it. Simplify to get one number, right? So you want to make a note of that for yourself. Whereas on the left side, you want to go ahead and factorize each one of these, all right? So factorize, and then the next one, you want to go ahead and factorize that as well. So as long as you're able to factorize that, you'll realize that you've essentially turned this from the general form into the standard form. All right, so here goes. You'll have x squared plus 4x plus 4 divided by 2 is 2, and 2 squared is 4. So x squared plus 4x plus 4. Now, if you want to think to yourself, what are two factors of 4 that when I multiply them, I end up with 4, and when I add them, I get 4. Those would be 2 and 2. And so therefore, this piece factorizes into x plus 2 whole squared, like that. Right, now let's repeat that process, but this time we have y squared minus 6y plus 6 divided by 2 is 3, and 3 squared is 9. So you have basically the number 9, and you're asking yourself the same question. What two numbers multiply to 9 but add up to -6? So those two numbers would be -3 and -3. So what we do is we add, right? We add, because the addition sign is still there. We add, and that's always going to be there, by the way, because this is the format of the equation of a circle. So we have y minus 3 whole squared, like such. And finally, on the right side, as we said, of the equation, we need to simplify to get one answer. Now, we know that this first piece over here is going to be the number 4, right? We know that gives us 4. We know this piece right over here gives us the number 9. So negative 12 plus 4 is negative 8, and negative 8 plus 9 is going to give you positive 1. So therefore, what we're going to have is the number 1 out of that. And so there's not much you can do with it. You simply move it forward and you write down is equal to 1. And there you go. Like this, you have created the equation of the circle. All right. So the equation of the circle was already given to you, but now what we've done is we've created into its standard form. Now what we're going to do is it asks us to graph, right? It asks us to graph the circle. And so we're going to graph this circle, and essentially you just need to tell two things about the circle. What is the center of the circle, and what is the radius of the circle, right? And if you don't understand how to tell those two things, just go back to the previous slide where we basically read the equation of a circle and were able to tell what the center and the radius were. And so in doing that, when we do it here, we reverse the signs, and so we end up with the center of negative 2 comma positive 3, and we end up with the radius of the square root of 1, which is basically a 1. So like this, we know the center and the radius of the circle. It's going to be a negative 2 comma 3, and the radius is going to be a 1. So using that, we move forward, and that center of negative 2 comma 3 is shown to you, and the radius of 1 is also shown to you. Right? But more than that, you want to make a note of labeling the 4 corners, if you want to call them corners, of that circle, because they really benefit you and they help you in understanding what the new coordinates would be and how the circle would look. All right? Because once you connect them, and if it doesn't look like a circle, then you clearly know that something actually went wrong there. All right. Now, it says that you're supposed to use a graphing utility to graph a circle. So what we'll do is we'll take a moment and we'll pull up a graphing calculator to graph the circle here. Now, first thing that you want to do is clear anything that's in your graphing calculator and go to the y equals menu. And then after that, notice how it says y is equal to. But the problem with what we have is this is literally x squared plus y squared is equal to 4. So we don't even have something that's y equal to, right? And the reason why is because our graphing calculators, they basically graph functions, right? Our graphing calculators graph functions, but a circle is not a function, right? A circle is not a function. And so what we need to do is we need to basically solve for y, all right? So when we solve for y, here's what that's going to look like. We'll have y squared is equal to 4 minus x squared, and then y is equal to plus or minus 4 minus x squared. But again, there's another issue, is the fact that there is a plus and a minus here. Your calculator will not understand what a plus or a minus is. It's again going to lead to something that's ambiguous. It's going to be two outputs for the same input, and that doesn't make sense for a calculator. It cannot compute that. So instead what you do is you separate these and you make one of them a positive and you make one of them a negative, like this over here. So it's still the same 4 minus x squared, but you put it into a positive and a negative. Basically what this is going to do is going to create half circles for you, and altogether you can treat those half circles as a full circle as you're looking at them. All right, so here we go. We're going to pick up our calculator, and in the top of the calculator I'm going to type in the square root of 4 minus x squared. And then in the bottom one, I'll type in negative the square root of 4 minus x squared, like that, okay? And again, you want to zoom to a window that's understandable. Now, I would zoom to a window that basically contains the center and it contains the radius. So For that, you need to kind of focus on this equation and think about how an equation should be of the format x minus h squared plus y minus k squared is equal to r squared. But if you have x squared and you have y squared is equal to 4, we get that the radius can be figured out. Now, if the radius squared is equal to 4, we know that the radius is going to equal 2. But the center is the kind of the tricky one for a lot of students is because they're like, wait, where did the h and the k go? So one way that you can look at it is, in fact, the h and the k are zeros, meaning the center is at 0. And the reason why is because if you write x minus 0 squared plus y minus 0 squared, they essentially do still give you x squared plus y squared. But what that does tell you, though, is the center must be at 0, comma 0. So we're basically looking for a circle that is centered in the middle, right? So the middle, it's at the origin, and it's going to have a radius of 2 throughout. But we're trying to see this inside of our graphing calculators. So when we want to see it, a good thing to do is to put a window that will actually make sense, right? So I'm going to make my window, let's say a -5 to a 5 on the x-axis, and a -5 to 5 on the y-axis. And I would recommend you do the same thing as well, because that way you'll fit the graph quite well into our calculator. And so what you see there initially, it only looks like it's basically these half circles, if not even. And you can zoom to a standard, perhaps it'll do a slightly better job. But the reason why it looks like the way it does is because your graphing calculator cannot exactly put a circle in there. You can zoom into different kinds of ways to look at it. You can try zooming to fit. And when you zoom to fit, sometimes it'll give you something that looks even weird and looks funkier, right? But these are the equations of that graph right there, okay? Again, it's a small skill, but it's something that you certainly want to pick up as you go along. Now what we're going to learn to do is basically take some descriptions of circles, some diagrams of circles, and write the standard form of the equation of the circle. So if you recall, there's a standard form and there's a general form. And the standard form always looks like this. X minus h whole squared plus y minus k whole squared is equal to r squared, like that. Okay? So let's go ahead and take a single example here, number 8. And number 8 shows us that there is a circle and it's got a center at 1, 2, and it's got a point on the circle, right? This is a point on the circle, and that point is 1, 0. But that's essentially all we've been given. So what we need to do is think about how can we determine these two pieces of the circle so that we may plug it into the formula of the circle. Now obviously one of the things is quite obvious, that the center is already given to us, so we can go ahead and write down that the center is 1, 2. That's really not that hard. But when it comes to figuring out what is the radius, one will imagine that essentially what that means is we need to find the distance from the center to a point at the end of a circle, right? On the circle. So to find this radius over here, we need to think about what have we learned in geometry that may actually help us, and at the beginning of pre-calculus, right? And so it turns out to actually find the radius, if you think about it, it's really the distance, all right? It's really the distance from the center, to the circle. So the idea here is we need to use the distance formula, all right? So let's go ahead and jot down the distance formula once again. The distance formula is d is equal to the square root of, I know it's been a while since we used this formula, but we need it here, so we're bringing it back forward. X1 minus x2 whole squared plus y1 minus y2 whole squared, like that. So let's go ahead and determine this by using the points 1, 0 and 1, 2 to figure out this distance. All right, so the radius is equal to that distance, so we'll write down radius is equal to, and then the square root of 1 minus 1 squared plus 2 minus 0 squared, like that. And so when we do something like that, we're going to end up with basically a 0 squared and then a 2 squared. So 0 squared plus 2 squared is basically 0 plus 4. And so we end up with the square root of 4. And the square root of 4 is 2. So once we have that, we now have the radius of the circle. The radius of the circle is equal to 2. So using these two recipes, 1, the center, and again 2, the radius, we may go ahead and create the equation of the circle. So the equation of the circle will now be x minus 1 squared plus y minus 2 squared is equal to 2 squared. All right? And if you want to go ahead and turn that 2 squared into the number 4, by all means do so. But this is the equation of that circle. All right, so similarly, let's take a look at number 10 here. Number 10, again, it seems to be giving us points along the circle, on the circle itself, but there is no mention of the center this time. Notice how this is the center, but we don't know the coordinates of the center. So this time, you got to realize that if we've been given 2 points that are on the circle, right? These are 2 points on the circle. Then we can essentially sketch a diameter through that circle. So you want to start thinking about how is the center related to the diameter. If you make a diameter of a circle, and diameter, recall from geometry, is specifically a chord that is running through the middle of the circle. So what that means is if we want to find the center, what we really need to do is we need to find the midpoint of the diameter. All right, so that's our foot in through the door. And once you can bring that logic through, then you have to ask yourself, what's the formula for the midpoint of a diameter or any line segment? And the midpoint formula used to go like this. It's add the two x's, x1 plus x2, and divide by 2, and then y1 plus y2, and then divide that by 2. All right, so that is the formula for the midpoint of a circle. And so what that means is if we can find the midpoint of this diameter, we will have found the center. So let's go ahead and write out that center. The center will therefore be at 2 plus 0 divided by 2, comma, 3 plus 1 divided by 2, like that. All right, and when we simplify that, what that gives us is a center that is going to be at 2 divided by 2, which is 1, and then 3 plus 1 divided by 2, which is 2. So the center is actually at 1, 2. All right, so we now know the center of the circle. And what that leaves us with now is to think about the radius. So the radius can be found in one of two ways. We can go ahead and find the distance of the diameter, and if we find the distance of the diameter, we can divide that by 2, and if you divide the diameter by 2, you end up with the radius, right? That's one way to do it. Another way to do it is to think about the fact that, okay, now that we know what the center is, so let's erase some of this stuff here. Now that we know that the center is actually located at 1, 2, what we can do is we can pick any 2 points. We can pick 0, 1 and 1, 2, or we can pick 2, 3 and 1, 2, and we can essentially do exactly what we did in this question over here, where we found the distance from the center all the way to its endpoint. So I'll leave that to you, however it is that you wish to do it. Um, but in general, if you were to go ahead and run, the second format that we were talking about, let's suppose we were to find the distance that is between the center and 2 comma 3, that would really quickly just be square root of 1 minus 2 squared plus 2 minus 3 squared. And if you simplify that, it's going to become negative 1 squared, which is basically, right, negative 1 squared, which is going to be 1. And then this is also a negative 1 squared, which is also 1. So therefore, your radius would be the root of 2, because 1 plus 1 is 2. And then using these two recipes, once again, we can really quickly make that equation of the circle. And the equation of this circle is therefore going to be x minus 1 squared plus y minus 2 squared is equal to the root of 2 squared. And one thing very neat that you want to kind of recognize is the root of 2, when you square it, it actually ends up giving you 2. Right? So if you see a 2 there, don't get misled that that's the radius. That's not the radius. The radius is actually the root of 2, as we discovered earlier. All right. Now, in these questions over here, essentially what happens is you read a description, and it's the same exact thing. So instead of having a, a formal picture, you instead have a description for you. Okay, so if you think about number 36, we will not do them completely, but I'll remind you of how exactly the same steps we took to complete a certain problem that was similar to it. Okay, so let's take number 36. All right, number 36 says that you've got a circle with a center of 1 comma 0, and it's containing the point negative 3 comma 2. So get to thinking, just if you were to make yourself a really quick sketch, all right, because a sketch really helps here. So here's a really quick sketch for you. All right, you've got a center that's at 1 comma 0. All right, so let's say that right there is my center, 1 comma 0, and that's my center. And then you've got a point on the circle. So these are each for a circle, and it's basically negative 3 comma 2 is contained on that circle. So let's go to negative 3 comma 2. Let's call this negative 3 comma 2 over here. All right, this is negative 3 comma 2. You know that this point is on the circle. Now, if you begin to actually draw the circle, this is where I'll leave you to it, is if you draw the circle, right? If you draw the circle such that that point is on the circle, you'll notice that this problem, right? I'll just make a note of it. This problem is pretty much the same as problem number 8. We had a center and we had a point on the circle. So this problem is just like number 8, right? I'll just leave a note here, just like number 8 that we did, because we essentially have a center and we have a point on a circle. So you want to kind of get used to the steps that you're supposed to take when you are put in that situation where you have a center and a point on a circle. And there's no sense in me doing that again, because I essentially did this in number 8, and eventually I did the same thing in number 10, right? But what I remind you of is you need to do what you need to do to figure out what the center is and what the radius is so that you can put it into the standard form. All right, number 38. Right, so remember, these, I'm not completing these fully. You still need to complete them, but I'm giving you some direction with them. Okay, so number 38. This one says that you've got a center at negative 3 comma 1. Okay, so let's draw this once again. Okay, so a big advice here is basically sketch. All right, sketch these, and it's going to make things a lot easier. So here goes. You're going to go to negative 3 comma 1. Let's make a little coordinate plane here. All right, and on this coordinate plane, we're going to go to negative 3 comma 1. Let's say that's about right here, and we're going to call that our center. All right, so negative 3 comma 1, and that is my center. Now, it says it's tangent to the y-axis. All right, so I just want to spend some time talking about what does it mean when a circle is tangent to the y-axis, right? So what we notice is the y-axis is right over here, right? It's right over here. So if the circle, think of a tire when it touches the road, the tire is only touching the road at one point, right? So if this is a road, then the tire touches the road right at one point. And basically, it turns out that whatever the center of the tire is, the tire is touching the road exactly below that, right? So exactly directly below the center. And so that is the reason why we go over to the y-axis and we label this as 0, 1. Now, how do I know that? It's because if the center was at -3, 1, meaning -3 on the x-axis and +1 on the y-axis, and now we're saying that the circle is tangent to the y-axis, that can only mean that this circle must be going through 0, 1, right? And so initially that seems rather confusing as to how we came up with that description, but once you kind of accept that, once again, you've got a circle. And how is this similar to something that we've done already? Well, think about it. We now know a center. All right, we know a center, which is at -3, 1. And we also know, once again, a point on a circle. All right, we know a point on a circle. And again, to reiterate, once you know a center and you know a point on a circle, you just simply do exactly what we did in number 8. And you can actually discover what the formula is going to be completely. All right, let's take a look at number 40. Number 40 says that you've got endpoints of a diameter at 4, 3 and 0, 1. Okay, so once again, let's kind of jot this down. So at 4, 3, right, let's suppose that this is 4, 3, right? And again, this is the endpoints of a diameter, right? So the diameter is going to be determined by these 2 points. And 0, 1. So 0, 1 would be over here on the y-axis, so 0, 1. So basically what they're saying is this line right here represents the diameter. That right there is a diameter of a circle. Well, think about how we just tried this a little while ago in a different question on the previous slide. So if you want, you can go ahead and make a circle, right? And that circle contains those 2 points, 0, 1 and 4, 3. Now, again, how did we figure out what the center, because we can't proceed if we don't know the center of that circle. To find that center, what we did, all right, so to find the center, what did we do? We used the midpoint formula, right? We use the midpoint formula. And once you have the center, then what you can do is you can actually find a radius. And the way that you find the radius is you find, okay, you find the distance from the center to either endpoint. And so where have we done this in order to finish the problem? We did this in number 10. So if you don't know how to complete these problems, just go back to a few minutes in the video where we did number 8 and number 10 thoroughly, and you'll discover that essentially it's doing the same exact thing. After you make the sketch, these problems are not much different, right? These problems are not much different than what we just discovered in the previous slide. Okay, now let's take a look at number 42. All right, number 42, we have just enough space to kind of fit that in right here. Number 42 has a center, and it's tangent to the line x is equal to 1. Okay, so let's go ahead and try to draw this out first. All right, so let's go to 4, -2. All right, so let's call this right over here 4, -2. And that right there represents my center. All right, so let me label that as the center. Now, what it says is this circle is tangent to the line x equals to 1. I want you to think about what type of conclusions did we make earlier when we had said that there was a tangent to the y-axis, right? So the line x is equal to 1, the line x is equal to 1 is essentially a line that's going down this way, right? And that is not the y-axis, but it basically has the equation x is equal to 1. So if this circle is tangent, right, we just discovered that whenever something is tangent, as we had talked about earlier, right over here, is if whenever something is tangent to a circle, you can go straight from the center to that tangent, and you know that that's going to be a point on the circle. And so what we mean by this is if we go straight from the center to that tangent line, this coordinate right here is guaranteed to be a point on the circle, and that is the point of tangency. And so what exactly is that point? Well, think about how we were at 4 comma negative 2. That's 4 on the x-axis and negative 2 on the y-axis, right? So what that means is this coordinate over here must be 1 comma negative 2, because we know that this is x is equal to 1 that this line was going through, right? So it's pretty neat. So that's x is equal to 1, and now we know that this is a coordinate on the circle, so we may go ahead and sketch the circle. All right, we may sketch the circle. And again, what does this really come down to? We know the center of the circle. Right, the center of the circle, once again, was given to us. It was at 4 comma negative 2. But we also know a point on the circle. And a point on the circle, all right, a point on the circle, which was a little bit more difficult to find, is 1 comma negative 2. Now, once again, after you have those two things, you can actually use the distance formula to figure out the radius, and the center is already given. Now, because this is one of the last questions that we do, let's kind of just go through that process really quickly. If we were to find the distance, right, so we're doing question number 42, right? If we were to find the distance between 4 comma negative 2 and 1 comma negative 2, what would that look like if you really need the distance formula? Because essentially that's just basically 3 units right there if you just kind of count from 4 to 1. But if you were to not notice that and try finding the distance, well, here it is, 4 minus 1 squared plus negative 2 minus negative 2 squared. That's going to give you 3 squared, which is 9, and negative 2 plus 2, which is going to give you 0. So altogether, the distance would be 3. So using the radius, right, this is the radius now, and this over here is the center, we can go ahead and create a really quick equation. X minus 4 squared plus y plus 2 squared is equal to 3 squared. So just like this, all the problems that we have not set up equations for, you could have done the same exact thing for all 3 of these problems and gotten to the same exact conclusion. All right, so one of the last things that we do in this section is we take a look at a circle, all right, and we're essentially going to stick to the standard form of a circle because of time constraints. We generally don't get time to take a moment and factorize all of these, because notice that these are all in the general form, right? They're in the general form, and you really can't tell much about them until you don't switch them into standard form. And so if you're wondering what is standard form is what we've been using. It's actually what the top 4, A through D, are labeled like, right? So here is the idea, here's the exercise. It says, which of the following equations might have the graph shown? So notice how in this, they're not really telling you any numbers at all, right? But a few things you can tell is definitely the center is going to be some negative x value, and the y value is 0. So that's one thing that you know. And you also know that it's going to have some kind of a radius, right? It's going to have some kind of a radius, but that's essentially all you can tell about this circle, all right? So now based upon this, you can actually figure out which one of these equations will work and which one of them will not, all right? So let's go through this exercise. and then we'll take a look at how much time we have left in the video, and possibly we'll spend some time turning from general form into standard form, although that takes some time because we've talked about how to turn things from general to standard on an earlier note, right, where we said graphing a circle whose equation is in general form, but it takes some time to complete the square and all that stuff, so that we can have it in standard form. So what that would entail is 4 times we would need to go through the process of going from general to standard in number 60 if we truly wanted to do E through H. So let's take a look at equation A, right? In equation A, can you tell what the center is going to be, right? In equation A, we can tell that the center is going to be at 2, 0. If you're looking at that's going like, why is it 0? Well, basically think about y squared, right? If it's y squared, it was actually y minus 0 squared. Just like you have x minus 2 squared, then you had y minus 0 squared. And notice that the 3, right, the 3, what it really represents is the 3 is not the radius. Be careful with this. Let me put this in red. The 3 is not the radius. What is it really? It is actually radius squared, right? So what we're saying is r squared is equal to 3. So what is the radius really? We learned that you have to take a square root, and that is actually the radius. And so the radius of this circle is therefore equal to the root of 3, which if you use a calculator and check, it's about 1.73. So notice that if this circle had a center at 2, 0, then it would have been on this side of the x-axis, which it's not. And so therefore, what that means is equation A cannot possibly belong to the graph that's shown to us. So equation A does not work for us. All right? Now, let's take a look at equation letter B. Equation letter B says the only difference is instead of x minus 2, it says x plus 2. Now, remember we talked about this. You always switch the sign on this before you tell what it is. So what that means is the center on this circle is negative 2, 0, right? And if it's negative 2, 0, now that makes a lot more sense. And notice how the radius is still marked as the same as before. So the radius here is the root of 3, which is 1.73. Now that makes a lot more sense. If this is the case, then look at what would be happening. We would essentially be having a center right over here, and that's at negative 2, 0. That doesn't seem to be a problem. And its radius is 1.73 units. That doesn't seem to be an issue either. All right. So in fact, what we can do is we can keep equation B. Equation B makes a lot of sense. All right, now let's take a look at equation C. In equation C, what it's telling you is the center is at 0, 2, and the radius is once again a root of 3. Now again, begin thinking, if the center was truly at 0, 2, then the circle would have been over here, which it's not, because 0, 2 is basically on the y-axis. And so what that means is choice letter C does not make any sense, and that can't possibly be the correct answer choice. Now let's take a look at answer choice D. This one's a bit tricky. If you think about it, the center is essentially the same as the center in letter B, right? So it's still negative 2, 0. So very innocently, you might think, yeah, well, that should work for us. But here's the problem. What is the radius in letter D? Right? What's the radius in letter D? In letter D, the radius is actually the root of 4, and the root of 4 is 2. Now, the reason why this doesn't make sense for the drawn diagram to be belonging to the equation D is because if you were to say that the radius is 2 units, that means that goes back to the origin, because look at where the coordinates are, negative 2, 0. So 2 units back the other way, this circle should have been a lot bigger. It should have been going like this if it truly had a 2 units of radius. And so that's a very tricky one, but it turns out that the equation letter D also does not work for it, right? So that one's a bit tricky. Now, if you take a look at the forms that are given to you, the rest of them, essentially what you need to do with each one of these is turn them into their standard form as we talked about, right? So we can take a moment and try one of them only, but at a really rapid pace. So here goes. To turn equation letter E into standard form, here's what we would do. We would begin by saying x squared plus 10x plus, and if you need a more detailed version of this, what you may do is you may go to a few slides back where we talked about this in detail, and then I'm just redoing that process. So you end up with x squared plus 10x plus 10x plus 10 over 2 squared. That's called completing the square. And then you have y squared plus, right? Now notice that there is no other y's here. And because there is no other y's, we don't need a plus. There is nothing else there. And so on the right side, what we're going to do is we're going to send the 16 over. So that becomes a negative 16. And we add to that anything that we use to complete the square. So we used plus 10 over 2 squared to complete the square. And so we're going to go ahead and add 10 over 2 squared. Basically, whatever you added on the left side must also be added on the right side. That was the idea. So if you're wondering why didn't you have to add anything to the y squared, is because in equation letter E there is no term that says any y's on it. Like in equation letter E, there was a 10x and an x squared, so we needed to complete the square. But there is nothing to match up with the y squared, so the y squared is on its lonesome, right? Just like the y squared over here, it actually leads to us saying y minus 0 squared. Now, here's what we have. We have x squared plus 10x plus 10 divided by 2 is 5, and 5 squared is 25, plus y squared. So if we know that this piece right here gives us 25, negative 16 plus 25 is 9, right? So this is 9. So altogether, when you factorize x squared plus 10x plus 25, you're looking for two factors of 25 that are going to add up to 10, and those would be 5 and 5. So you end up with x plus 5 squared plus y squared is equal to 9. And so after all of that work, we can tell that this is a equation that's saying that the center is at negative 5 comma 0, and the radius is the square root of 9. Always remember this, the square root of this number. So the square root of 9 is 3. Well, again, let's think about this. If this center was at negative 5 comma 0, that's fine. All right, we can agree with that. And if the radius is 3 units, that doesn't seem like it's a problem, because if it was 5 units, then that would have been going right back to the origin, which cannot be happening, at least in this diagram. And so, in fact, it turns out that the letter E is an acceptable letter. Now, because of the length of this video, I will not do F, G, and H, but basically, you spend your time completing the square in F, G, and H to match it up with which one might be the correct possible answer. All right, so thank you for watching the lesson, and good luck in completing the homework.